At the 2013 Tractormania Casade event, a large Winterthur two-cylinder diesel engine was proudly running, attracting attention from vintage machinery enthusiasts. This powerful engine, featuring a massive flywheel, was operated manually by several men, demonstrating the skill required to manage such machinery. Winterthur, a renowned brand produced by Sulzer Brothers in Winterthur, Switzerland, is known for its reliable and robust diesel engines. These large two-cylinder engines were commonly used in industrial and marine applications, providing dependable power for demanding tasks. The live demonstration highlighted both the engineering heritage and enduring appeal of classic diesel technology. This is a massive 9-cylinder diesel engine showcased at Tractormania Casade 2013. Its imposing size dominates the display, revealing the complexity of large-scale diesel engineering. The engine features robust piping, heavy-duty cylinder covers, and a network of gauges for monitoring performance. Designed for high torque and endurance, it exemplifies classic diesel craftsmanship. During the demonstration, the engine runs smoothly, emitting a deep, resonant sound characteristic of multi-cylinder diesel power plants. Observers are often fascinated by its mechanical intricacy, sheer scale, and the visible motion of its pistons and valves, highlighting the engineering marvels behind large industrial engines. This is the smallest Russell steam engine, demonstrated powering a shingle mill at Mount Pleasant, Iowa in 2018. Though Russell steam engines were more commonly used for agricultural tasks such as threshing, plowing, or pumping, this engine showcases a less typical application, driving a shingle mill. The engine's mechanical power is transmitted through a belt drive system. The flywheel rotates, transferring motion via a belt to operate the mill's saw and the carriage that feeds logs to it. This setup allows the steam engine to efficiently cut shingles, demonstrating its versatility beyond conventional uses. Russell & Company, a prominent manufacturer of steam traction engines, produced models ranging from small, compact engines to larger, high-powered machines suitable for heavy belt work. The adaptability of these engines made them valuable in both industrial and agricultural settings. While their primary roles historically included hauling, pumping, and threshing, the use of a Russell engine to power a shingle mill highlights the engine's capacity to perform a wide variety of tasks wherever mechanical power was needed. This example not only preserves the operational history of steam technology, but also illustrates the ingenuity of early industrial applications, where one engine could drive multiple types of machinery, depending on local requirements and available equipment. The 1940 Atlas Imperial engine displayed at Mystic Seaport in 2016 stands as a remarkable example of early marine power engineering. This robust diesel engine, once widely used in workboats and small commercial vessels, showcases the durability and precision of mid-20th century machinery. Its heavy cast iron construction, exposed valve gear, and rhythmic firing cycle attract visitors whenever it is started during demonstrations. Maintained in excellent working condition, the engine highlights both historical craftsmanship and the skill of modern preservationists. At Mystic Seaport, it serves not only as a functional exhibit, but also as a vivid reminder of America's maritime industrial heritage. The Wolverine engine at Mystic Seaport is gradually coming back to life, with steady improvements made each week. In this run, the team introduced cooling water, uncovering numerous leaks that were carefully traced and sealed. A small magnet was mounted on the flywheel to operate an electric tachometer powered by a 9-volt battery. Although it briefly worked, the magnet shifted to the flywheel's outer rim. Even so, the engine now starts more easily, despite still shaking vigorously due to the lack of a secure mounting base. Once placed on its final display stand, it will run far more smoothly, but it is already thrilling to watch. A Kenworth, powered by the legendary 1693 Cat motor, represents the rugged era of heavy-duty mechanical diesels. This 14.6-liter inline-six delivers 325 to 425 horsepower and enormous low-end torque, making it a favorite for demanding hauling work. Its bold, dual overhead camshaft design, rare for trucks of its time, gave it exceptional durability, though it also earned a reputation as a fuel hog due to its hot-running pre-combustion chamber system. Cold starts required glow plugs and a 24 volts series parallel setup, while regular valve adjustments and persistent gasket leaks were part of routine maintenance. Despite its quirks, the 1693 remains admired for its brute strength and vault-like build. The featured popcorn machine is a classic steam-powered model crafted by C. Creeders & Company of Chicago as indicated on its polished brass front plate. Its vintage design highlights the early engineering behind traditional popcorn making, offering both charm and historical value. With its distinctive mechanisms and timeless aesthetic, the machine evokes the atmosphere of old-fashioned fairs and community events. Today it stands not only as a functional device, but also as a nostalgic centerpiece that showcases the enduring legacy of early popcorn production. The Hitura Diesel V12B is a robust 12-cylinder engine representing the company's long legacy of building large diesel power units. Hitura Diesel produced hundreds of engines until 2000, with its largest model being an 18-cylinder version rated up to 3,850 horsepower. The V12B shown here is installed on the company's test bench for training and verification. Today, the company continues to service and repair the many engines still operating worldwide, found in submarines, ships, hospital backup systems, industrial plants, nuclear facilities, and offshore oil platforms. This is the 145-year-old original Schmidt water motor, built in 1871, motor number 5. Designed to deliver up to 1.5 kilowatts, it originally ran solely on water pressure up to 6 attu. In practice, the engine uses oil lubrication, so for environmental reasons, water operation is limited. Today, it is demonstrated at vintage engine events using diesel exhaust for safe operation. In this video, the motor powers a generator to showcase its functionality. Its ingenious design, visible in action, illustrates early mechanical engineering. The stationary motor Christoph and Unmac, built in 1931, is a remarkable example of early stationary engine design. Featuring a single-cylinder configuration, this robust engine has an impressive displacement of approximately 8 liters, reflecting the engineering standards of its era. Originally intended for industrial and agricultural applications, it exemplifies durability and simplicity, characteristics highly valued in early 20th century machinery. Its large cylinder and slow revving operation allowed for steady, reliable power output, making it suitable for driving pumps, generators, or other stationary equipment. Today, it stands as a fascinating historical artifact for engine enthusiasts and collectors alike. The stand motor Christoph Barockschloss is a stationary engine designed to remain fixed while delivering reliable power. Unlike mobile engines, it does not move its frame during operation, making it ideal for driving pumps, generators, or other industrial machinery. Typically powered by large internal combustion or steam systems, these engines have historically supported various sectors, including agriculture, construction, and manufacturing. Their robust design ensures continuous and stable performance, even under demanding conditions. The stand motor Christoph Barockschloss exemplifies this engineering tradition, combining historical significance with practical utility, demonstrating how stationary engines have long powered essential equipment in industry. The 1930 Ottawa log/drag saw is showcased at the St. Croix Valley Early Day Gas Engine and Tractor Association Branch 1 display during the Almalin Threshing Show in August 2018. Part of the Nelson family collection, this vintage saw highlights early 20th century logging technology. Operated manually or by belt drive, it reflects the ingenuity of its era, providing a fascinating glimpse into historic timber cutting and farm industrial machinery practices. The 7-horsepower monitor saw rig is a remarkable antique farm machine, powered by a Baker Monitor VJ vertical 7-horsepower gas engine. Mounted on a portable saw frame, it features a hit-and-miss governing mechanism, spark plug ignition, and belt-driven operation. Produced by Baker MFG, Company of Evansville, Wisconsin. These rigs were widely used in the early 20th century for heavy-duty tasks like cutting wood, grinding corn, and powering other farm equipment. Its wheeled cart design allowed easy transport across the farm. Production ceased around 1925 with electrification, making surviving examples highly valued by antique engine collectors and enthusiasts today.
Prony is sponsored by Alliance Industries.
At the Forest City, Iowa show on June 6 to 7, 2019, a Rumely Oil Pool Z engine was showcased running on the new Prony brake. This demonstration highlighted the engine's mechanical simplicity and rugged reliability, traits that made the Oil Pool series a favorite among farmers in the early 20th century. The engine was carefully mounted in the test blocks, allowing visitors to observe its operation under load. As it ran, the Prony brake measured its output, recording a performance of just over 50 horsepower, an impressive figure for a single-cylinder, heavy-duty stationary engine. The Oil Pool Z's distinctive hit-and-miss governing system regulated speed automatically, making it both efficient and easy to operate. Spectators were treated to the rhythmic chugging of this historic engine, alongside the visible motion of its large flywheel and exposed components. This demonstration not only showcased the engine's functional power, but also celebrated a piece of agricultural engineering history. The Fiat S76, famously known as the Beast of Turin, roars to life with ear-splitting, flaming exhausts at the Goodwood 77th members' meeting. Built in 1911 by Fiat, this extraordinary racing machine was designed to challenge the land speed record set by the Blitz-Benz. Its colossal 28 353cc engine produces an impressive 290 horsepower, a remarkable feat for its era. Although its initial runs fell short of the ultimate goal, the S76 still managed to achieve a record-breaking speed in 1911, showcasing Fiat's engineering ambition. With its massive engine, aggressive design, and thunderous presence, the Beast of Turin remains an iconic symbol of early automotive daring and the relentless pursuit of speed. This 7-cylinder, air-cooled radial engine is a 670 cubic inch power plant once used on World War II landing craft. Producing approximately 250 horsepower, it represents the rugged reliability required for wartime operations. Today, the engine is proudly owned by a Mystic Seaport employee and remains a standout attraction at the annual Mystic Seaport Engine Show each August. Its distinctive radial layout, rhythmic firing sequence, and historic value always draw crowds, offering visitors a rare chance to see and hear an authentic World War II-era engine come to life. A GM diesel generator is a large, heavy-duty power unit designed for continuous industrial operation. The system uses a multi-cylinder diesel engine, known for its durability and stable output, to drive an electrical generator supplying reliable power to factories or facilities. In the image, technicians are performing maintenance on the massive engine block, checking covers and control systems to ensure proper performance. The unit features extensive intake piping, a robust cooling network, and a dedicated control cabinet for monitoring engine functions. Overall, this generator represents a dependable solution for demanding, round-the-clock power requirements.